Hello, this is Mr. Miller and welcome to video 6a. In this video, we're going to talk about translating and checking inequalities. Here we go. So, first we want to review what the different symbols mean. There are four different inequality symbols, and we need to be familiar with all of them. The first one, this one is less than or fewer than. The next one is less than or equal to. This third one is greater than or more than, and this last one is greater than or equal to. All right. You may remember from when you were a little kid and doing inequalities that the alligator eats the larger one. So in this situation, the alligator is eating the 8. That means that 8 is greater than 6, or another way to think about it is 6 is less than 8. On this one, alligator is eating the 4. So 4 has the bigger part of the symbol. It's the larger quantity. This one says 4 is greater than 3. Okay, so on these, we want to kind of translate these symbols into words. So on the first one here, I see that 2 has the fatter part of the symbol. It's the one the alligator is eating. So 2 is greater than 0. That's how we would translate that one. 2 is greater than 0. On the next one, we see that this is the less than or equal to symbol. So we can say that negative 4 is less than or equal to 14. Okay, and that's true when either one of those is true. It's true if it's negative 4 is less than 14, which it is, or it's true if negative 4 is equal to 14. Which it isn't. So negative 4 is less than or equal to 14. All right. Often we have a variable, and as we'll talk about further when we kind of do a little bit more, I would read this from the point of view of x. All right. So x is what? This one says x is greater than or equal to 2, and this is how we'd write that. Okay. Well, we're going to translate these verbal expressions into symbols. We're going to write the math equivalent of these. So this first one says negative 4. So negative 4 is less than, okay, so that's this symbol, negative 2. Okay, and that's true. Negative 4 is more negative than negative 2. It is less than negative 2. All right, 37, okay, that's what we're starting with, is greater than, okay, so here's the greater than symbol, 19. The sum of 6 and 7, all right, so the sum of 6 and 7 would be 6 plus 7, is less than 20. Okay, so here's the less than symbol, and 20, right? The remaining ones involve a variable. X is less than or equal to 2. So less than or equal to. So x less than or equal to, there's the symbol for that, to 2. Okay. X is greater than 8. So we have x, we want the greater than symbol, 8. So whatever number x is, it's greater than 8. All right, y is greater than or equal to x. So we have variable y. Greater than or equal to is that symbol. Greater than or equal to x. Okay, so now we're going to circle inequalities that are true and cross out ones that are false. And if we need it, we have a number line down here to help us. So 2 is greater than 5. That is definitely false. 7 is less than or equal to 12. Well, it's less than 12, so this is true. Negative 5 is greater than or equal to negative 1. This time I'm going to go to the number line. Negative 5 is right here. Negative 1 is right there. The number on the left is a smaller number, so negative 5 is less than negative 1. This is not true. 4 is greater than or equal to 4. Well, 4 is equal to 4, so this is true. 9 is less than 9. No, it's equal to 9. This doesn't have the little equal symbol underneath the inequality, so this one is false. All right. Sometimes we're going to be asked to put a number into an expression for a variable and see if it's true. So does x equal 6 satisfy the inequalities? It means put 6 in for x and see if what we get is true. So if we do that, we get 6 is greater than 8. No, that's not true. All right. Let's put in 6 into this one. We get 6 is less than or equal to 10. Yeah, that's true. All right, so whether an inequality like this is true or not depends on the value of x we put in. So putting 6 into this one, 6 plus 4 is less than or equal to 7. Well, that's 10. That's not less than or equal to 7. So this one is no. And putting 6 into this one, we get 2 times 6 plus 3 is greater than 14. That's 12. 2 times 6 is 12, plus 3 is 15. That is greater than 14, so that works. All right, we're going to take this a little bit further. We have a beautiful inequality here, and we want to check which numbers satisfy it. So we'll circle it if it satisfies it and cross it out if it doesn't. So we just got to take turns putting these numbers in. We're used to equations that normally have one solution. Inequalities usually have many solutions. So let's put in 20. Is 20 minus 17 greater than 4? Well, 20 minus 17 is 3. That's not greater than 4. No, that's not a solution. Let's try 24. 24 minus 17, is that greater than 4? Well, 24 minus 17 is 7. Yep, that's greater than 4. How about 35? 35 minus 17? Well, yeah, that's 18. 18 is greater than 4. That's true. Let's try 21. 21 minus 17, is that greater than 4? 4 greater than 4? No. That one's bad. The last one, negative 5 minus 17, is that greater than 4? Well, that's negative 22. That's definitely not greater than 4. That's less than 4. So that one's bad also. So when we're doing these, we just have to substitute the numbers in inequality and see if it makes it true. Right on this one, we're going to put 2 in for x. 3 times 2 plus 10. That equals 16. Is that less than or equal to 19? Yes, it is. That works. 3 times negative 2 plus 10. That's negative 6 plus 10 is 4. Is that less than or equal to 19? Yep. That works. 3 times 4 plus 10, that's 12 plus 10 is 22. No, that's not less than or equal to 19. 4 doesn't work. Put in 3. 3 times 3 plus 10, is that less than or equal to 19? Well, this is equal to 19, so that works. And finally, negative 12. 3 times negative 12 plus 10 is negative 36 plus 10 is negative 26. So when I put negative 12 in, this side is negative 26. Yeah, that's less than or equal to 19. That one works too. So of the 5 numbers, 4 of them worked. All right, well, that's enough for now. Here's a journal assignment for you if you want to show your teacher you understand all of this. All right, take care. Keep doing math.